Hello everyone. Today I'm going to explain continuous integration and how important it is for software engineering. So I told you before that software engineering is about multiple people working on a project that will have multiple versions. So if you have multiple people in your project, of course, you're going to expect some challenges, but of course it has its advantages as well. So to be able to deliver a project faster, multiple people attack the same project, but they have to work in parallel. Otherwise, they're going to wait each other. This synchronized work will slow things down. So you have to make them asynchronized. They can work on their pieces without waiting for other people to finish their pieces. So version control systems like Git helped people to work on the same project in parallel. But of course, we are all human. We can make mistakes. These mistakes can include projects that cannot be compiled or built, or we also have to make sure that the tests are running, unit tests, integration tests, or whatever tests you have, automated tests. And so you have to find ways to facilitate multi-person team. When multiple people work on the same project, there are some team practices that you develop, and some of the practices, for instance, code readability, maintainability, consistency, and you will have automated tools that does that or partially check those criteria. For instance, static code analyzers, and you want to make sure that code does not introduce any regression so that you have your unit tests. And so many other things, linters, for instance, that you have, right? And you want them to be executed for each pull requests. And pull request is a request that you create when you want your branch to be merged in the master branch. Of course, this kind of brings us to Git concepts, right? I'm not going to go into much detail about Git, but Git has a branch usually called master branch, and that is the source of truth that every other developer branch off of when they want to work on their piece of work, so that when they finish their work in their branch, they create a pull request for others. Again, this is not a pull, but a pull request. And you basically say, hey, I've done my work, but I need people to review this to make sure that it is readable, consistent, functional. Just be a second pair of eyes looking at this work besides me. And then let's make sure that it is working fine before we actually merge that into the master branch. Because once it is in master branch, other people will depend on it. So your aim is to put a piece of code that will not disturb others, their workflows, into the master branch. With continuous integration, you address it in two ways. First, you constantly integrate your code into the master branch so that you can reduce the merge conflict, so that people can use your code earlier, and so that you can actually help them to review your code easily, because when you have a large change set to be reviewed, that's really a pain for a lot of developers. And the other thing is, as part of the continuous integration, you run your automated steps on every pull request, and that helps. So what does this automated step include? They include running your unit tests. They include compiling your project. That includes building your projects to make sure that everything is looking good before people can actually merge your change set into the master branch. So without further ado, let's go ahead and see how we can do this on Azure DevOps. So I've chosen Azure DevOps because that is something I've been using for years now, and that is something is free, by the way, for your own personal use. It is also a really powerful tool that you'll find a lot of things that help you. So let me show you how you can actually go here. All you have to do is just say devazure.com. This will take you to your dashboard where you can create new organization. And organizations can include multiple projects, and you'll see what a project is. And a project can include multiple repositories. So repository is basically a Git repository. Or you can choose a different source control system to host your code. I already have an organization here with my name, with my username. Underneath it, I have a project called Prime Seller. So a project contains your work items, a wiki, boards, build pipelines, release pipelines, pretty much everything that you need to manage a project and deliver a project to your customer. So underneath it, I have one single repo, and you can have as many repos as you want. For instance, you can import repos from other repos, for instance, from GitHub, from registries like GitHub. You can manage your repositories. You can create a new repository and push everything from your local computer to here and all that stuff. It's really powerful. And under repos, you can see various other tabs to see different aspects of your repos, branches, commits, pushes, everything. You have pipelines. So since this video is not about Azure DevOps, I'm gonna dedicate a different video for Azure DevOps. So I'll continue with my continuous integration topic. I'm looking at my repo right now, and it's a very simple project. It has just one method in it, is prime. And then underneath that prime service, a unit test project that has multiple tests in it. Okay, so what I'm gonna do is to start integrating continuous integration into this project, I need to create a pipeline first. Okay, here, I'm gonna go ahead and create a pipeline. And a pipeline is a group of jobs, and each job has a group of steps. And a step can be running a script, or running your unit tests, or running your static code analyzers, and so on. There's so many steps you can define, and there's so many steps that are already defined by Azure DevOps that you can just use. And let me actually show you how that looks like. So let's say create a pipeline, and then I'm gonna choose Azure Repos Git. Again, you have multiple selections here. You can pull your projects, the source code, from GitHub or other locations. I'm gonna use Azure Repos Git here, and already have my repos showed up. Well, for this example, just as a starting point, I'll go ahead and choose ASP.NET Core. And what it does, it creates a new file that is called Azure Pipelines YAML. You can change the name of it, but I'm just gonna keep it as it is. And as you see that it's a YAML file, it is a superset of JSON, sorry. And you can specify your steps here. And this will have only one job. And my step, the first step that is automatically added here is .NET Build. I'm gonna change it. I'm gonna remove the steps here. And I'm gonna say show assistant. There is this assistant that shows you all the available steps that you can use. And I'm gonna use .NET Core. And if you use this assistant, you can actually manually type it in here if you want, if you know all the attributes for that step. But if you use this, it actually sometimes offers you a GUI where you can actually choose things like this. The first step I want to execute as part of this pipeline is build. And if you look at this tooltip here, it tells you where to find your CS projects easily. And I'm just going to copy this wildcard. It supports wildcards, so I'm going to copy this. I'm just going to put it here. So instead of specifying all the projects individually, I'm just going to use a wildcard to choose them all. That includes unit tests, whatever files that ends with CS proj extension. So I'm just going to say add. So as you see, it automatically added over here. So let's add another step, and this time I'm going to be running unit tests. So let's say test here. Again, this time I only want to choose unit test proj file. So what I'm gonna do, I'll go to Files, and we'll find the location of my csproj file here, and that is this. So let's click that. I'm gonna copy this, and let's do this. Really easy, and that looks good. So it's gonna be added over here. So say add. Good. So one problem is there's no display name, which I want to display a proper, easily understood task name. You'll see where that names are displayed in a second. But if you look at this link here, it takes you about this task link. So let's click that. And you can learn more about this task on the documentation of Microsoft. And you see what available attributes are and all that stuff. And here, this is the attribute I was looking for, display name. So let's copy this and put it over here. And for this, I want this to be running or building the project. By the way, you have to be careful about the formatting of your YAML file, and if you see something like this, it says invalid YAML structure. Just make sure that you have proper spaces. So I'm just going to put a space over here. So let's copy the same thing for the next task. If you're not familiar with YAML, I will definitely recommend you to just read their specification and some documentation about YAML to get yourself familiar with it. And this step is, okay, this looks better now. So you can have as many steps as you want. You can define your own steps. For instance, you can just, for instance, if you look at this, if you want to run a PowerShell script, you can do that as well. You just say, you either do an inline PowerShell with this within this task, or you can say, this is my PowerShell file I want you to run as part of a step. Just for brevity purposes, I wanna keep this job very clean, very small. Okay, so let's say save. So what happens here is that this Azure Pipelines YAML file will be saved into my project, into my source code. And ideally, I don't recommend it to work in master branch, but just for this project, that's okay. And then you can just commit this file into the master branch directly. So let's save this. Okay, perfect. So if I look at my files, I'll see that file over here, Azure YAML, Pipelines YAML. Okay. So let's go back to the pipelines here, and now I have my pipeline, prime seller. I usually like to change its name to specify what this pipeline is about. If it's a CI pipeline or continuous integration pipeline, I specify that in the name. So something like this. To me, that's more descriptive, but it's up to you and up to your practices. So let's go ahead and run this pipeline real quick to see how that looks like. And if you click the job here, you can actually see all of the steps that are going to be executed as part of this pipeline. So the checkout means it actually pulled your projects into the agent. So these pipelines are executed on an agent. An agent is simply a server, and your code has to be downloaded on that server, and then these steps will be executed on that server with your source code. So let's look at the build project, and you see that it actually found, let's make this smaller, the available project files, and ran .NET build command. You can just see it over here. It ran the .NET build command on those project files. So things are looking good for this step. The second step I created was running the unit test, and these are display names, by the way. Remember, like I was going to show you where that display name attribute is used, and this is the place, the titles. And you can also see that it ran some tests. It found the project here, and you can see all of the logs that are outputted when this step is executed under this section here. Before we go back, let me actually show you something real quick, and that is this Tasks tab. If you click the Tasks tab, you can actually see how many failures you get, how many of your tasks actually passed. And if you change the filter, let's say passed, you can also see the stack traces associated with that with that unit test. If there's any stack trace, of course. The stack trace is usually attached if it's a failed test. And what's the error message is, if there's any work items associated with it. A work item is basically a bug or a story depending on the process you've chosen. For instance, there are multiple processes Azure DevOps supports, like Agile, Scrum, Basic, and others. And then if there's any attachment or history, like so. Cool. So let's go back. So we want this pipeline to be executed for two events. The first one is whenever a pull request is merged into the master branch. We want to keep the master branch stable and well taken care of. So we want to execute that when something is merged. And also we want to run this for each pull requests as a policy, because you don't want to merge something that fails. You don't want to merge a piece of code that breaks unit tests, that is not compiled or cannot be compiled, that cannot be built. You don't want to merge this in. So you have to have a mechanism that tells you beforehand if something will break your master branch. Okay, so the first step is, let's say edit. And then here we'll say triggers. And under trigger, we want to override the continuous integration, and we want to enable it. So I'm enabling the continuous integration right here. And I want this pipeline to be executed for master branch. So whenever master branch changes, this pipeline will be kicked in automatically. So let's save this. Okay, before I show you the second step, and that is for running this pipeline for each pull request, let's go ahead and change something and see the difference between a pull request that doesn't have the build pipeline enabled and the one that has it enabled. So there are a couple ways you can make changes on this project. For instance, you can locally change it, and you can push your changes to the remote report, which is here. But I'm just gonna change it here on the browser with this button here. And I'm gonna run true. So let's say commit. And now I can actually specify a different branch, because I don't want to merge this into the master branch. I want to create a pull request for it. So let's say fix as the name of the branch. And I have fixed the branch or code, let's say. And I want to create a pull request automatically. Okay, so let's change the name of it. I probably had a branch name like that before. So let's say fix 2. Okay. So you can see what I've changed here from false to true. And you can add reviewers. You can add work items. These two are really important, and we use these two fields all the time. We specify who is going to review this PR. Again, review process is really important, code reviews. And the work items tells us the underlying context or the background for why this change is introduced. So I'm going to create a pull request here. Okay, this looks good. But there's nothing here that tells me automatically if this change set will break my compilation, build, or my unit tests, except for the promise of the engineer. Like the engineer can tell me, hey, I've run everything locally, unit tests, build, compile, I compiled the project locally, everything looks good. But again, we are human and we can make mistakes, we can forget things, or things can change. And so we have to make sure before we actually approve this PR and then complete this PR. Of course, this is my PR, and usually what happens is that someone else comes here and approve this, and then if I get like multiple approvals from the engineers from the team, I complete this. So complete means go ahead and merge this into the master branch. But again, there's nothing that tells me or prevents me merging this in if this actually breaks something. And this takes me to other point in the continuous integration, making sure that everything is looking good before you merge that in. So what I'm gonna do is there's a setting here, and if you look at the branches for master branch, I want to create policies. So policies is basically ways for me to enforce rules on people. And I can say, I want at least this amount of people to approve this PR that goes into the master branch. So basically any PR that is targeted for master branch has to be approved by this amount of minimum amount of people. And you can change this 1, 2, 3, whatever. I'm not going to do that. I mean, I definitely recommend this to you, but for the sake of this demo, I'm not going to do it. And you can also enforce other things. You say, I want every pull request to be associated with a work item. I want to know what this PR addressing. And if people added comments on your PR, you basically can say, I want all of those comments to be addressed and resolved for this PR to go into the master branch. And the last thing I want to show is, and that is what I'm here, the build validations. What I want to do is that, as it says here, validate code by pre-merging and building pull requests changes. That's important. I want to run my continuous integration pipeline on this PR to make sure everything is looking good. And you choose your build pipeline, and it's a prime seller CI, and it's automatic, and it is required or optional. If it's required, it must succeed in order to complete pull request. Okay, so this is required, so I'm gonna just save this. That looks good. So let's save the changes. So of course you have to recreate your PR, and this is the PR that doesn't have the build pipeline running. So I'm gonna abandon this. Let's abandon this. And I wanna create a new pull request that shows the setting that we just did. Okay, you can of course give a better title and better description, and make sure that you give actually better title and better description for the fellow engineers to understand what you have done in your PR. And I'll create this. And now you see policies here, and a policy is initiated. It says it's required, so the build in progress. So this will run the build, and I can see if everything is looking fine. Perfect. It actually caught the error. It says there's a problem with your PR. So if I go back to my PR, you see that the build failed. It failed because I made a change that broke a unit test. And so I can go in here, I can look at the tests, and I can see what tests are failed. And this is a failed test, and I can see an error message here. Good. I can see the stack trace here. I can see if there's any associated work items or not. But you shouldn't merge this in. And with the help of this policy and continuous integration, you now know that if you merge this PR into your master, you would break your master. And then that means you were going to disrupt the other engineers' work because of a broken code. So this is continuous integration for you. I hope that it helps you understand and truly appreciate software engineering and continuous integration's role in software engineering. Until next time, stay safe.